Okay, welcome to video lesson 11.3 on simplifying rational expressions. In this section, we're going to have to utilize what we've learned in the previous chapters about factoring to be able to simplify the rational expressions by factoring and then divide out the common factors. Okay. Now, a rational expression is an expression that can be written as a fraction whose numerator and denominator are polynomials. Okay. Values that make the denominator of the expression 0 are excluded values. That shouldn't have an I in it, sorry about that. Just simply excluded values. Okay, we'll X out that I. Right, now how to simplify rational expressions. Okay, a rational expression will be in simplest form when the numerator and denominator have no common factors except 1. And in order to simplify a rational expression, we need to factor the numerator and the denominator and then divide out any common factors. Okay, so there's some examples written out in algebra. If a, b, and c are polynomials, and where b and c aren't equal to 0, because they're in the denominator, they can't be 0 there, then if we're factoring that out, we'd factor that out into the products, a times c and b times c, and then c are both in common in the numerator and denominator, so we divide them out, and we'll be left with a divided by b. Okay. Similarly, with an actual example, if we have 2 times the quantity x plus 1, and then divided by 5 times the quantity x plus 1, the x plus 1, okay, and the numerator and denominator would divide out, cancel each other out, and we'd be left with 2/5. And we have to tell what the excluded value is, and in this case, of this example, x could not be -1, because then we would be taking in the denominator -1 plus 1 is 0, and 0 times 5 is 0, and remember, we can't ever divide by 0, that's undefined. Now in example 1, these are quite blurry, sorry about that. We'll rewrite them here. Okay. So we have to simplify the rational expression if we can, and then state the excluded value. So the first thing we want to do is to get these into factors. So we want to kind of get the prime factorization of the number 12. Well, the number 12 in prime factors would be 2 times 2 times 3, okay, because that would be 4 times 3 is 12, and then over 2 times x, okay. Well, factoring that out, now we're going to divide out anything that's common. Well, the only thing that's common are the 2's. Then we can simplify what's left over. So 2 times 3 is 6 over 2x's multiplied together is x squared, okay. And now we just have to state what value of x will make the denominator 0, or what is our excluded value. And if x squared equals 0, to solve that we would take the square root of each side. So we can do that. X squared equals 0, then I'm solving that by taking the square root of each side. And the excluded value is x equals 0. Okay, so we don't want x to be 0. All right, and that would be our simplified rational expression there. Now in part B, okay, we have n divided by n plus 8. Okay. Now notice here this is n plus 8. If this would be n times 8, we could simplify this to 1 over 8 and divide out the n's. Since this is technically n plus 8, okay, it is already in simplest form. Okay. We can't simplify it anymore, but we still have to say what the excluded value is. The excluded value, x cannot be equal to -8, because if x were equal to -8, then the denominator would be 0. Okay. Now for part C, I'll just rewrite this first of all so it's easier to read. Okay. First thing that we want to do is to write out the factors. Okay. The prime factorizations basically. So 6 times y is just 2 times 3 times y, and then y minus 7. Okay. Now we'll cancel out or divide out the common factors. So we have a 3 and we have a y that's in common. So then we're left with y divided by 2y minus 7. Okay. And we can't simplify this anymore. Okay, now we just have to list our excluded values. So we know that x cannot be 0, because 0 minus 7 would be negative, well, 0 minus 7 is negative 7. I gotta do that again. 0 minus 7. 7 times 2 is negative 14. But 0 divided by negative 14 would still be 0. And y can't be 7. Okay? Oh, that's the problem, sorry. The reason we want to use the excluded values with the original equation. Sorry about that. Okay, so we're not going to go off the denominator of the simplified one, you're going to go off the denominator of the original one. And if we come back here and if we have 0, okay, 0 minus 7 is negative 7, but 6 times 0 is 0, and so 0 times negative 7 is 0. And that's why 0 is also an excluded value, not just 7, which 7 being here in the original equation will still make this side 0, and so 0 times 42 would still be 0. Okay, so always remember that when you are finding excluded values, to use the original expression. Okay, and I'll write that down. Use the original expression. To find, oops, excluded values. Okay, so always use the original expression in order to find the excluded values. Very good. All right, now we have example 2. Basically the same thing, but now instead of just finding, canceling out or dividing out the common factors, we may have to actually factor or use the difference of two squares patterns, all of those different things that we've learned. So for part A here, we have 1 minus z squared. We need to use the difference of two squares pattern there to rewrite that, okay? And we're going to write that as 1 minus z and then 1 plus z. Okay, and I will just make my z's like with a line through so you can tell that they're z's. And then we have that over z minus 1. What we want to do now is rewrite 1 minus z up here. Okay, so we're going to rewrite this 1 minus z as negative 1 times z plus 1. Okay, or sorry, negative 1 times z, not plus 1, but minus 1, because that would be negative z, which is what we have, and then positive 1, which is what we have up here. Okay, now when we do that, so I'm rewriting this as negative, basically z minus 1, and then 1 plus z over z minus 1. Now I can cancel out common factors, which would be z minus 1, so we'd be left with negative 1 plus z. Okay, and now we need to know our excluded value. So going back to the original expression again, what value of z can we not have so that it won't be 0 in the denominator? So z would have to be 1 in order for it to be 0. So we do not want z to be equal to 1. That's our excluded value. Okay. Now in part B, we're going to have to factor out both the numerator and the denominator. So we need factors of c squared plus c minus 12. Remember again, we want factors of negative 12 that will have a sum of positive 1. Okay. So that will be c plus 4 and c minus 3. Okay, product is negative 12, but the sum is positive 1. And then for the denominator, we need factors of negative 20 that will have a sum of negative 1. So that would be negative 5 and positive 4. So c minus 5 and c plus 4. Okay, now we can divide out any common factors, which would be this c plus 4. Okay, and we're left with c minus 3 over c minus 5. Okay, and that's our simplified rational expression. Now we need to go back to the original equation and figure out what our excluded values are. Now, this is just here, we factored it here. So from this factored form, it's still the original equation, just in factored form. And there it will be really easy to tell, since it's factored, what the values will be for c when x equals, or when the denominator is 0. So we have c minus 5 set equal to 0. Then c cannot be equal to 5. Okay? And if we have c plus 4 equals 0, then c cannot be equal to negative 4. And those are our two excluded values, which is easy to actually find the excluded values when we have the denominator already in factored form. All right. Now we have example 3. This is a real-life example. And it says, in general, as the surface area to volume ratio of a substance increases, it reacts faster with other substances. And we want to write and simplify the ratio for the block of ice that has the dimensions as shown. Okay, so the width x, length x, and then the edge height of 2x. All right, so the surface area to volume. Okay, so what will the surface area of this rectangular prism be? Okay, well that will be 2 times the bases, so x times x, that's the front and the bottom, okay, plus, then we're going to have 4 sides that are found by doing 2x times x, which would give us 2x squared, okay, and then the volume is just x times 2x. Okay, so we'll write it out like that, and then we can kind of simplify this. Okay, so 2x squared plus 8x squared basically is what we're left on the top, right? Over 2x to the third. Okay, and then we can simplify 2x squared plus 8x squared since they have like terms, the variables and the exponents are the same. So that will just simplify to 10x squared over 2x cubed. And now we need to divide out common factors. So 10 divided by 2 will be 5. And then we have 2 x's here. So 10 divided by 2 again was 5. And if we have x squared divided by x to the third, okay, what do we do with exponents when we're dividing again? We're going to subtract them. So we're going to be left with, it would really be 5x to the negative 1, which means we have 5 over x to the 1. Okay? So 5 over x is what this is simplified. Okay? And that's all we have to do. We don't have to put excluded values for this. All right, so now we simplified the ratio of the surface area to the volume of this particular block. Will be 5 over x. Please write down any questions that you have about simplifying rational expressions, and be sure to ask them during our next class. Thank you. Have a great day.